Dear grade 9, we are with the chapter 2 polynomials. Today let's move on to our new lesson, zeros of a polynomial. First of all, let's see how polynomials are represented mathematically. It is represented in the form of p of x, not necessarily p of x, always it can also be represented by q of x or q of y, f of x, things like that. A small letter, and in the bracket you will have the variable. Now let us see how to find the zero of a polynomial. Zero of a polynomial can be found out by equating the expression equal to 0. Let's see with an example. Here is an example polynomial p of x is equal to 2x plus 5. This is a polynomial because the power of x is 1 and there are two terms. So specifically this is a binomial. Okay, so our lesson today is to find what is the zero of this polynomial. So first step, there are two steps. First step, we put the expression. We just rewrite the expression and write equal to 0 because we are going to find the zero of a polynomial. And step 2, just to solve for the value of the variable x. And you know how to solve it. We just replace, keep moving one by one, plus 5 changes to minus 5 on the other side. These two get cancelled. So on the left side, we will have only 2x. And on the right side, 0 minus 5, negative 5. And then the last step is to keep x alone. We have to move times 2 as divided by 2. And that's your answer. So x is equal to negative 5 by 2. Or negative 2.5 is the answer. So we can say that negative 5 by 2 is the zero of the polynomial. We can even check, or why do we call this as a zero of a polynomial? You will understand from that. Look at this value. X, we get the answer as negative 5 by 2. So let us replace this value in this equation. Our expression was 2x plus 5. Now we are going to replace the value of x by the answer that you got now. 2 times 5, negative 5 by 2 plus 5. And you know 2 is in the numerator and this 2 is in the denominator. They get cancelled. So what's the answer that we get here? Negative 5 plus 5, which is equal to 0. That's why then the name is zero of a polynomial. In short, the meaning of zero of a polynomial is that we replace the variable in a polynomial by a constant number so that the whole expression turns to be a zero. Such constant or such number which will give you the whole result of the polynomial equal to 0 is called a zero of a polynomial, or it is also called as root of the equation. So we have the equation here, see, because you have an equal sign. P of x is equal to 2x plus 5. So when you replace x by negative 5 by 2, you get the answer 0. So we call it as root of the equation. What is the root of the equation? Negative 5 by 2. Okay, now let us see a term that you studied in the previous lesson. What is constant polynomial? We studied that constant polynomial means a polynomial which only has one term with a number. There will only be a number. There is no variable here. So p of x is equal to 4 is a constant. See, from the word itself, constant means a fixed number. 4 is a constant polynomial. Negative 3 by 5 is a constant polynomial. Why this topic is here again? To know that what is the zero of a constant polynomial. Because we studied that the zero of a polynomial means a number which we replace for the variable to get the answer 0. But here there is no variable. So see the result? Constant polynomial has no zeros. Why? Because we don't have a variable with the constant. So there is no zero for a constant polynomial. What about zero polynomial now? zero polynomial is just one situation. In the whole world, we have only one case, what is called a zero polynomial, when the polynomial is just a number 0. So the number 0 itself is called a zero polynomial. And what, can you guess what will be the 0 of this polynomial? 0 of a zero polynomial. Think about 0 can be multiplied by any variable, 0 times x. It's the same. So can't you replace x by 1? Yes. Can't you replace x by half? Yes. Can't you replace x by root 2? Yes. Can't you replace x by pi? Yes. So here is the answer. Every number, every real number is a 0 of a zero polynomial. So what is the root of this equation? The root of this equation is any number that you find in this world as a root of this equation, because you can multiply 0 by any number. Okay, now let's move on to another example to find the root of an equation. So we studied that 0 of an equation, 0 of a polynomial, can also be said by another term, which is the root of an equation. So I took an example here, p of x is equal to x minus 7. So how do we find the 0 of polynomial? 2 steps. Step number 1, very good. Step number 1, we put the expression equal to 0. Step number 2, we solve for x. Here solving is very simple. We just replace or we transform minus 7 as plus 7. So x equal to 7 is the 0 of the polynomial, or we call it as root of this polynomial. Great. Let's move on to next part of the same lesson. The second part of this lesson is find the value. Find the value of the polynomial at x is equal to 1, which means we have to replace x is equal to 1 in the given polynomial. Let's do an example. So this is a polynomial of 3 terms, or this is a trinomial specifically. Find the value, which means we replace x by the given number. The given number here is 1. Excellent. So we just replace wherever you have x, even in the left side of the representation of the polynomial, we replace it by 1. X is replaced by 1. So x power 3, 1 power 3, minus 1 power 2 plus 2. We are just replacing wherever you have x, replace it by the number 1. So 1 power 3 is 1, minus 1 power 2 is 1, plus 2. 1 minus 1 is 0. And what's your final answer? 2. So the value of the polynomial x cubed minus x squared plus 2 at x equal to 1 is 2. Okay, now let us combine the two objectives of this lesson. First objective is to find the value of the polynomial. They will give you what are the values to be replaced. We have to replace x by 1 in first case, and in the second case, we have to replace x as 2. In the polynomial, p of x is equal to x squared minus 2x. So let's take the first case, x is equal to 1. So replace all the values. X is 1 here, p of 1 is equal to 1 power 2 minus 2 times, this is not x, this is times, 2 times, what's the value of x? First case is 1. So 1 square is 1 minus 2 times 1 is 2. 1 minus 2. They used to make some silly mistake here. It is not 1. 1 minus 2 is not 1. It is negative 1. Great. So we are done with the first part. In the second part, we have to find the value of this polynomial at x equal to 2. So we can replace the equation by p of 2, x is replaced by 2, is equal to 2 power 2, because x is 2, 2 power 2 minus 2 times the value of x is again 2. Don't forget, we have to follow the order of operation with mass. So 2 square is 4 minus 2 times 2 is 4. 4 minus 4 is 0. So the value of this polynomial at x equal to 2 is 0. Okay, now let us see the same expression in the form of finding the 0 of the polynomial. So the same expression is here. P of x is equal to x square minus 2x. Find the zero of the polynomial. Don't forget, find the zero of the polynomial means we follow two steps. What are the two steps here? Great. Step 1, we write the expression as equal to 0. Second one, we solve for x. How do we solve? Here you can see that you have x is common in both the terms. Here you have x, also here you have x. So you can take x outside. So when you take x outside, from x square, if you take one x out, what's left now? One x is left because x times x is x power 2. Minus, from 2x, I took x outside. So what is left? 2 is there. So x times x minus 2 is equal to 0. Now, we can say that, how do we get this equation equal to 0? Either x is equal to 0, or the second bracket is equal to 0. X minus 2 is equal to 0. So we take two cases. X is equal to 0 or x minus 2 is equal to 0. In grade 8, you have studied about factorizing an equation. So this is actually an application of that one. X is equal to 0 or x minus 2 is equal to 0. So x equal to 0, we don't have to solve. That is one of the answer. And another answer is x minus 2 is equal to 0. We can solve it. Negative 2, when you transform, it will change to be a positive 2. So x equal to 2. So what are the zeros of this polynomial? We have two zeros for this polynomial, x equal to 0 and x equal to 2. So we understand that x equal to 2 is a zero of the polynomial, which means you just move back to the first part of this question. P of 2, when you replace P of 2, we get the answer 0, which means 2 is a zero of the polynomial, or 2 is the root of this equation. Why? Root of the equation means a number which you replace for the variable, you will get the whole answer 0. And that's the same thing that you got here. So these are the two objectives of this lesson. To find the value of a polynomial, we just replace x by the given number. Second one is to find the zero of the polynomial, we follow two steps. Usually in this lesson, you will have only power 1. This I gave you as a recall or previous knowledge from grade 8. You will have only power 1, so you will have only one root. So to find the zero of a polynomial, we follow two steps and we get the answer. Let's move on to the exercise. First question, find the value of the polynomial. Find the value means we replace the value of x by, first we have three cases. First we have to replace by 0, then by -1, and then by -2. So we have to solve case by case. Now, first let us see P of 0. We are replacing P of 0 is equal to 5 times 0 minus 4 times 0 power 2 plus 3, which is equal to 5 times 0 is 0 minus 0 power 2 is 0 times 4, again 0 plus 3. So your answer is 3, right? Okay, now let us see the second part of it. What's the second part of it? P of -1. P of -1, we replace the value, or the x will be replaced by -1. So 5 times -1 minus 1 power 2 plus 3. 5 times -1 is -5. -1 power 2 is 1. So -4 times 1 plus 3. Now -5 will stay there. -4 times 1 is -4 plus 3. Now we have two negatives, -5, -4. Same sign, we add. So -9 plus 3. Now we have different sign. When you have different sign, we subtract. -9 plus 3 is -6. Hope that is clear. Now the next example. By replacing x equal to 2. So when you replace x by 2, P of 2 is equal to 5. We replace the x by 2, 5 times 2 minus 4 times 2 power 2 plus 3, which is equal to 5 times 2 is 10 minus 4 times 2 power 2 is 4 plus 3, which is equal to 10 minus 4 times 4 is 16 plus 3. Now we have to follow the order of operation. Here it is plus and minus, we subtract. So negative 6 plus 3. Now we have different sign, so we subtract. Your answer is negative 3. Is that clear? Let's move on to question 2. Again, find P0, P1, P2 for the polynomial P of y is equal to y square minus y plus 1. So first let's take one by one. P0. P0 means we replace it. P of 0 is equal to 0 power 2 minus 0 plus 1, which is 0 square is 0, 0 minus 0 plus 1, which is equal to 1. That is the first case. Second one, P of 1. So we can write P of 1 is equal to 1 square minus 1 plus 1. Nothing, we are just replacing it here. Okay, which is equal to 1 square is 1 minus 1 plus 1, which is 1 minus 1 is 0, and you have plus 1 is the answer again. Let's take the third case, P of 2. P of 2, how do we replace? Is equal to y square, so which is 2 square minus 2 plus 1, which is equal to 2 square is 4 minus 2 plus 1. 4 minus 2 is 2 plus 1, which is 3. Finish, we are done. Let us see another example. P of t is equal to 2 plus t plus 2t square minus t cube. Again, we have to replace P0, P1, P2. So let us see P0. P0 is 2 plus 0 plus 2 times 0 power 2 minus 0 power 3, which is equal to 2 plus 0 plus 0 minus 0. Finally, you will get the answer 2. Easy, right? Next question is to replace P of 1, which is equal to 2 plus 1 plus 2 times 1 power 2 minus 1 power 3, which is equal to 2 plus 1 plus 2 minus 1. Because 1 square is 1, 2 times 1 is 2. And 1 cube is 1, which is equal to 2 plus 1 is 3, 3 plus 2 is 5, minus 1, 4. And the last one from this, P of 2 is equal to 2 plus 2 plus 2, because it is 2 plus 2, plus 2 times 2 power 2 minus 2 power 3, which is equal to 2 plus 2 plus 2 times 4 minus 8. 2 square is 4 and 2 cube is 8, which is equal to 2 plus 2 plus, remember to multiply first, 8 minus 8. 2 plus 2 is 4, 4 plus 8 is 12, 12 minus 8 is 4. So these are all the values of the polynomial when we substitute or replace by the value of t by 0, 1, and 2. Let's move on to the next part of the same question. P of x is equal to x power 3. So we replace P of 0, which is equal to 0 power 3, which is 0. Again, P of 1 is equal to 1 power 3, 1. P of 2 means 2 power 3, 2 times 2 times 2, which is 8. These are the three values when you replace this polynomial by 0, 1, and 2. Next, again, we have to replace the value of x is equal to 0. So P0 is equal to 0 minus 1 and 0 plus 1. First bracket is negative 1 and the second bracket is positive 1, and you know 1 times negative 1 is negative 1. Now we have to replace by 1. So P of 1 is equal to 1 minus 1 and 1 plus 1. 1 minus 1 is 0 in the first bracket and 1 plus 1 is 2 in the second bracket. Anyway, your answer will be 0 because 0 multiplied by any number is 0. Now let us replace by 2. P of 2 is equal to 2 minus 1, 2 plus 1, which is equal to 1 times 3. 1 times 3 is 3. So these are the three values of x minus 1, x plus 1 when you replace 0, 1 and 2. Question 3. Verify whether the following are the zeros of the polynomial. First question, P of x is equal to 3x plus 1, where x is equal to negative 1 by 3. You are given a value of x. We have to see it is a zero of a polynomial. When do you say that it's a zero of a polynomial? When you get the answer 0 by replacing. So let us replace x by negative 1 by 3, which is equal to 3. It's always better to put them in a bracket, especially when you have a negative sign. Plus 1. This 3 and this 3 get cancelled. So we have the answer negative 1, this negative and this one. Negative 1 plus 1, which is equal to 0. Because you get the answer 0, we say that negative 1 by 3 is a zero of the polynomial. So whenever you get a 0, we say that the given value of x is a polynomial. Let's see the next case. P of x is 5x minus pi, and we have to replace x by 4 by 5. So P of 4 by 5 is equal to 5 bracket 4 by 5. This bracket is not necessary. You can just put a times there, no problem. Now 5 and 5 get cancelled because they are in the numerator and denominator. 4 minus pi is not equal to 0. Not equal to 0. So what do we say? So 4 by 5 is not a zero of the polynomial. Okay. Now let's see the next example. Okay. X is equal to 1 and x equal to negative 1. We have to replace two values. So first let us see P of 1 is equal to 1 square minus 1, which is 1 minus 1 equal to 0. So we can say that 1 is a 0 of the polynomial or of the P of x. Next, let us replace P of negative 1. Negative 1 power 2 minus 1. Negative 1 power 2 is also equal to negative 1 times negative 1 is positive 1. 1 minus 1 is 0. So again, we can say that negative 1 is also a 0 of the polynomial. Is also a 0. Okay, now let's move on to fourth part from question 3. P of x is equal to x plus 1 times x minus 2. So first we have to replace by negative 1. So P of negative 1 is equal to negative 1 plus 1, negative 1 minus 2, which is equal to negative 1 plus 1 is 0 times negative 3. 0 times any number is 0, so the answer is 0. So we can say that the value that you substitute, which is negative 1, is a 0 of the polynomial. Second part of this, we have to replace P of 2. P of 2 is equal to 2 plus 1, 2 minus 2, which is 3 times 0. Again, your answer is 0. So we can also say that the second value, which is 2, is a 0 of the polynomial. So you can see that there are two roots for this. -1 is a root and 2 is also a root of this polynomial. Let's see the next one. P of x is equal to x squared. So we replace the value by 0. P of 0 is equal to 0 power 2, which is equal to 0. We get the answer 0. So we say that the value 0 is a 0 of the polynomial. 0 is a 0 of the polynomial. Why? Because when you replace the value of x, you get the answer 0. Now the next one, question 6. We have to replace by negative m by l. So we say P of negative m by l is equal to L bracket negative m by l plus m. L in the numerator and the denominator get cancelled, and we get the answer negative m plus m. Negative m plus m is 0. Yes. So again, we get the answer 0. So we say that negative m by l is a 0 of the polynomial. Okay, there is only one value in question 6. Now question 7, there are two values. So P of negative 1 by root 3 is equal to 3 bracket negative 1 root 3 power 2 minus 1, which is equal to 3. Remember, you have to expand the power first. So negative 1 times negative 1 is 1, and root 3 times root 3 is 3 minus 1. Numerator and denominator 3 get cancelled. 1 minus 1, which is equal to 0. Again, we get the answer 0. So we say that this is a root. Negative 1 by root 3 is a root of the polynomial P of x. Next, we have to replace the value 2 by root 3. So we replace 2 by root 3. P of 2 by root 3 is equal to 3 bracket 2 by root 3 power 2 minus 1. We expand the power, so it is 4 by 3 in the bracket minus 1. 3 in the numerator and denominator get cancelled, so it is 4 minus 1, 3, which is not equal to 0. So we say that 2 by root 3 is not a root or not a 0 of the polynomial. Okay, now let's move on to question 8. We have to replace by the value 1 by 2. So P of 1 by 2 is equal to 2 bracket 1 by 2, 2 times 1 by 2 plus 1, which is equal to this 2 and this 2 get cancelled, 1 plus 1. This is also not equal to 0. So we say that 1 by 2 is not a root. We can say in both the ways. It's not a 0 of the polynomial, 0 of P of x, or it is not a root of the polynomial. Now let's move on to the last question of this lesson. Find the 0 of the polynomial. Don't forget, to find the 0 of the polynomial, we follow 2 steps. Step number 1, we write the expression is equal to 0. So let's start. X plus 5 is equal to 0. Now we transform x5 to the other side. So x is equal to minus 5. So how do we rewrite? Minus 5 is the root of the equation. Minus 5 is the 0 of the equation, or is the root of the equation, or the polynomial, we can say. Question 2, we have to find the root. So step 1, we write the expression is equal to 0. We solve it. X is equal to 5. So we can say 5 is the root or 0 of the polynomial. Question 3. To find the root, we write the expression is equal to 0. First, we have to move 5. 2x is equal to minus 5. Plus 5 changes to minus 5. Then times 2 changes to divide by 2. So we can say that negative 5 by 2 is the 0 of the polynomial. Now, next one is p of x is equal to 3x minus 2. Again, we rewrite 3x minus 2 is equal to 0. 3x is equal to 2. Minus 2 changes to 2. Or x equal to 2 by 3. So we can write 2 by 3 is the 0 or root of the polynomial. Okay, now question 5. Again, we have to find the root of the polynomial or the 0 of the polynomial. So we replace 3x is equal to 0. So x is equal to 0 by 3, which is equal to 0. So we say that 0 is the root of the polynomial or 0 of the polynomial. Question 6, ax, where a is not equal to 0. So we say that ax is equal to 0 or x is equal to 0 by a. Did you see? A is in the denominator. That's why they gave you the condition a is not 0. Because you know that if you have a 0 in the denominator, it is good. It is not defined. So we say that x equal to 0 is the root of the polynomial or is the 0 of p of x. Now we have cx plus d. So step 1, we write the expression is equal to 0. Then we solve for it. Plus d changes to minus d, and x is equal to minus d by c is the root of the polynomial or is the 0 of the polynomial. That's all for this lesson. Now the homework part, we have to find the value. Find the value p of 2 and p of minus 2 for this polynomial, and we have to find the 0. To find the 0, follow 2 steps. That's all for today. Keep practicing. This really needs practice. This is really easy. Thank you for watching. Have a wonderful day. See you in the next period. Bye for now.